Okay, so in this video, we're going to talk about how to understand, match, and plan the merge sorted arrays problem. Now, you're going to actually see kind of this problem again in later problems, and so try to remember how this problem works because it's very helpful in sorting algorithms and other kinds of algorithms where you've got to take two ordered sequences and put them together. Okay, so given two sorted integer arrays. So we know that our input is two arrays of sorted integers, okay? Now it's nums1 and nums2. What we're gonna do is we're gonna merge nums2 into nums1 as one sorted array. You can see the number of elements initialized in nums1 and nums2 are m and n respectively. And then you can assume that nums1 has enough space. So this matters a little bit more in something like C or a really strongly typed language. In Python, you can dynamically resize lists pretty simply, and so, but for the purposes of this challenge, we're going to consider this to be full of enough blank spaces. Okay, so let's talk about how are we going to solve this. Okay, so I understand that my inputs are these two lists of ordered integers, and that anytime I see a 0 like this, I'm going to have to assume that it's not part of the sequence, but instead like a blank space. Okay, so then nums2, that's basically, the length of nums1 plus the length of nums of the zeros, right? And then our output is not going to be a new list. That's something that's really important here. What's coming out of this function doesn't matter. What we're doing is we're modifying nums1 in place. All of the tests expect you to have changed nums1, so they'll be checking the passed in value. So in Python, you want to remember that nums1 is not like redimensioned when you pass it in. You're just passing in a reference to an object that already exists outside. So let's just make ourselves kind of our own little test case, right? So what we want to do is say, okay, nums1, I'm going to call it like first list, just so it's called something different in the global scope. And then I'm going to give it my example here. And then second list is my other example. And now if, let's say we'll call merge sorted arrays on first list and second list. And then if first list is equal to this, yeah, and then we can say print it pass, right? Actually, I'll just go ahead and print first list because I don't think that that's how that works. Print first list. So once my first list looks like this, then I know that I've passed. Okay, so I've set myself up a little test and I've understood kind of what's going on. This can be a good way of telling yourself that you understand what the inputs are. Okay, so now what I want to do is match. Now, what I'm going to be doing, I know, is looping over both lists, but I want to think about, okay, so recently I've learned about binary search, right? And so in the binary search problem, I'm really just holding on to pointers, right? Rather than like looping through the elements in the list. And I know that what I'm going to be doing here, since this 5 isn't necessarily going to be like here, right? We're not just zipping the two lists together. We're actually, taking them and putting them in their correct positions. So I know that sometimes I'm going to get ahead of the first list when I'm pointing to this, or I'm going to get ahead of the second list when I'm pointing to this first list. Sometimes I'm going to be behind it. So I know that I'm going to need like two sort of pointers, one to point to a spot in nums1 and one to point to a spot in nums2. Okay, so let me think. I have 2 pointers here, okay? So I'm just going to kind of make myself a diagram. So I like to do this. We'll say that my pointer 1, I'll call it x, and my pointer 2, I'll call it y. So I'm going to compare the element at position x with the element at position y. And if the number is smaller in the first list, I know I need to increment x, right? To check to see if the number is smaller here as well. Okay, so then I'm going to compare the element at x and y, and since they're the same, I'm just going to go ahead and insert right here, since they're the same. So when I do that, I'm going to go ahead and move y over, and that way I won't be checking x anymore. Okay, and then I'm going to move x over. Okay, and then I'm going to compare x and y. They're not the same, so I'm going to move x over. Okay, and 5 is much bigger. So, okay, I'm going to compare x and y. X is smaller than y, so I'm going to keep looking. Now that I've reached an empty space, I know that there are no numbers bigger than this in this direction. And so what I can do is just go ahead and put my 5 here. But I need to get rid of a number. And I also needed to get rid of a number before, like a little spot at the end, because I inserted 2. So there's going to be like a removing elements at the end kind of thing going on. Okay, and then I'm going to move my pointer over here, and now I've got a 6. And I'm just going to move it over, and I found another blank spot. So I'm just going to insert a 6 there, and then remove that last item. Okay, so I feel like I've got a good approach. I'm going to just write this down. So I need a pointer for nums1. So I need a nums1 position or index. And then I need a nums2 index. That's the x and the y here, respectively. Okay, and then those are going to start at 0, both of them. You don't want to start anywhere weird. And now I don't want to keep going after the end of my second list. So while nums2 index is not greater than the end of the list. So while nums2 index is not greater than, well, it's less than the length of nums2. Okay. Now, so let's see, what did I do here? In the beginning, I checked to see, just move that back. Okay, so in the beginning, what I did is I checked to see, okay, 1, is that larger or smaller than 2? And so I need an if statement here. If nums2 at nums2 index is greater than nums1 at nums1 index, okay, or equal to. So when that happens, what I'm going to do is I'm going to insert nums2 index, nums2 at nums2 index into nums1 index, nums1 at nums1 index. Okay. Else, I'm going to increment the nums2 index. or no, sorry, nums1 index, because I'm trying to find the place to put it in nums1. So nums1 index plus equals 1. Once I've found a place to put this, I need to also nums2 index, I need to increment it. And then that other thing that I needed to do was remove an element at the end of the list. Let's see. The other thing that I did was once I got to the end of the list, let's see. I'm going to make sure that I've got a 0 in each one of these spots. I had a 3 here. Yeah. So I started with this, right? So when I found an empty spot, a 0, I knew that it was okay to put the number there. So I'm going to say or the spot in nums1 at the nums1 index is 0. So if it is, then I know that it's safe to put something there because I've already reached the point where every number bigger than, like I've already found a number in nums2 that's bigger than every number in nums1. So I can just sort of put them there in order. Okay, so how are we going to translate the rest of this into Python? I'll show you in the next video.